So, applications. Okay? Fancy way of saying word problems. Okay? But don't freak out. Don't get all crazy. Okay? Because most of the word problems have the formula right in them. Okay? It's right there in them. Okay? Most of them. Most of them. Okay? So, page 867, let's talk about Gina. She's a social, easy for me to say, social media manager, and she uses the model for continuous population growth to project the monthly increase in the number of followers in her client's social media sites. Okay? We've actually done very similar problems to these. Okay? Recall that the formula for continuous population growth is that. State what each quantity represents in terms of this problem situation. So, n sub 0 would be what? What's that going to be? It's like PERT. Okay? So what's P in PERT? Starting amount. Okay? How much you start with? Okay? What's R? Rate of decay or growth. Yep. T. Time. Okay. E. It's just E. Right? E is E. Okay? All right? So, Gina claims that when she started working with an up-and-coming boy band, they had 18,450 online followers, and she was able to increase their followers by 26% per month. Use Gina's claim to write a function to represent the number of online followers that the boy band had after T months. Okay? So, let's call it B for boy band of T is going to equal, how much did she start with, or how much did 88.4 degrees, I'm trying to think of it, because there's 98 degrees, and there was, what was New Kids? So, New Kids on the 88.4, what's another boy band? Direction. Don't act like you're not impressed. Okay. How many did they start with? 18,450. And then we got E, right? What's our growth rate? 1.26. No. 0.26. Yep. Because it's E, it's just 0.26 T. Now, if this were the other one, where it would be 1 plus, then it would be 1.26. But this one's E. So that's my function. Yeah, buddy? Yeah. Yeah, yay. If Gina started working with the band on May 1st, so we're talking in months, how many followers did it have by September 1st? Okay, well, what's the difference between May and September? So, May, June, July, August, September, right? Did I miss a month? I don't think so. Okay. So 1, 2, 3, 4, right? Right? May 1st to June 1st is 1, to July 1st is 2, to August 1st is 3, to September 1st is 4, right? Okay? Calculate me. How many followers New Kids on the 90 or 88.4 degrees direction have? Well, you tell me. Why do I not want to do decimal points here? I can't have half of a follower. I mean,
if they're not dedicated.
yeah, if they're just not into it, they're just not into it. You know what I mean? How many we got? How many followers does this band have now?
52,199.
So we're going to round that to 52,199. Yep, because we got 0.05391. Yep. Okay. How long did it take the band to surpass 100,000 followers? So now we've got 100,000. That's only 10,000. That's 100,000. Is going to equal 18,450 times e to the 0.26, and we're looking for now t. We can handle this one. Okay. What would you do first, based off of what we learned yesterday and the day? And the day before. Okay, so we're going to divide both sides here by 18,450. Now, I hear people typing calculator stuff. Tap those brakes. Okay. Let's do it. Let's do all of our math first. Then we'll go to the calculator. All right. Trust me. Trust me when I say that. I'm even gonna. I think I have a. Oh, it's not big enough. I thought the. See, I got these like sliding pockets in there, and I thought one of them would fit a cell phone or fit a calculator, but not gonna happen. All right. So then we've got 100,000 over 18,450 equals e to the 0.26 t power. Okay. Got my exponential all by itself? Yeah, I do. Okay. So now what do I do? Switch forms. Okay. So this is going to become what? When I switch forms. But we don't say log base e, do we? We say natural log instead. Okay? So log base e is natural log of and that's going to equal 0.26 t. Okay? So now let's go to the calculators and let's figure out what the natural log of that fraction is. So I get 1.690105,816. And I'm going to leave that on my calculator. Okay? And that's going to equal 0.26 t. Now, how do I solve this for t? I'm going to divide this by 0.26, and that's going to tell me that in 6.5 months, our boy band will be more than 52,000 or more than 100,000 followers. Logically, does that make sense? Why?
Because over time you're slowly increasing.
Why does, look, you can see the entire page. Why does that make sense that after 6.5 months, we'd be over 100,000? Rubes, why does it make sense? It's growing, okay, but is that the only reason why? What you got? So we went, in 4 months, we went from 18,000 and change to 53,000. Okay, right? Right? And we're growing, and so we're growing, right? So then in 2.5 more months, we'd probably go over the top of 100,000. Okay? That would be the logic, more so than that it's just growing. I get that it's growing, but it could be growing really slow. You know what I mean? But because at that 4-month peak, we were already halfway there, and so we were going to go faster and faster and faster in our growth. So, okay? Try number 3. So, he's got 100,000. Oops, got to get the old marker on. He's got 100,000 or 105,326 followers right now. He started with 4,125. Okay? We don't know what R is, correct? But how many months have gone by? 36, because it's 3 years. Each year has 12 months, so that's 36 months. Okay, we need to solve this one for R. So I'm going to divide both sides by 4,125. Okay, so then that gives me 105,326 divided by 4,125 equals e to the 36r power. Okay. Switch forms. When I switch forms, I get the natural log of that bad boy. Is equal to 36r. So I figure out what that is. The natural log of 105,326 divided by 4,125 is 3. Whoa. Is 3.23994282. And so to find R, I'm going to do what with that? Divide that by 36, and I get a 0.899998 equals R. So I would call that a 9% growth rate. I would say growth rate, yes. Because otherwise it was decay, you know what I mean? We could have a 9% decay rate. Okay. Write an exponential function now to represent the online followers quarterback of any given month, assuming the number of followers continue to grow at the same rate. So then that would be, we'll say Q of T is going to equal 4125 e to the 0.09 t power. Why did I go with 4,125 instead of 105,326? Yep. So 105 was after 3 years, right? Or 105,000 was after 3 years. That's what we started with when she got hired. So that would be any month that she has. Okay? With me? Alright. So, what? I know, there's a whole other page of questions too. Was it on there? I don't think it was on there. Was it on there? Oh, C was on there. How long would it take to double? Okay. So how long would it take to double his current following, right? Okay. So sure. What's double of that? 210,652 is going to equal. Now what can I use for any month? Because I want to double it from here, from his current spot. So what's my starting value then? Right? Because my growth rate stays the same. Now, when I divide by 105,326, what do I get? 2. Oh, yep, because that is. Did I miss that up here too? Nope, I got that up there. Okay, yep, 0.09. Okay, oh, then I got to move the other one too. Okay, now what? Switch forms. So what does my switch form become? Natural log of 2. Natural log of 2 divided by, I get T here is equal to 7.7 months. Agree? Okay. Now let's go to cracking the case. Okay? I'll give you 10 minutes to get through E. Okay? So, first off, you got to kind of read and see what this formula is all entailing. Okay? All right? So, T is, capital T I should say, capital T is the body's temperature in Fahrenheit. Okay? Capital R is the constant room temperature. Little t is the elapsed time since death. Okay? So, at 8:30 a.m., a coroner was called to the home of a person who had died. The constant temperature of the room where the body was found is 70 degrees. So 70 here is, what's 70? R. That's my capital R. Okay? At 9 a.m., the body's measured temperature was 85.5 degrees. What's that? This is capital T then. Oops, that's a bad looking T. Now it's a good looking T. Okay? Use this body temperature to estimate the time of death. Okay? So I'm looking for little t then. And that's going to equal the, that's going to equal -10 times the natural log of capital T, which was 85.5 minus 70, all over 98.5 minus 70. With me on that? Okay. So 85.5 minus 70 is 15.5. 98.6 minus 70 is 28.6. Agree with that? So the natural log of 15.5 divided by 28.6 is negative that times negative 10 gets me a t-value here of 6.126, and that's going to be hours, right? So what time was that? We measured all that stuff at 9 a.m., right? So 6.126 hours ago. Well, what's 0.126 in terms of minutes? 7, right? Call it 8 minutes, right? So I am estimating the time of death, TOD, is 6 hours and 8 minutes ago, which would be 2:52 a.m. Yes? Because we're not looking for t there. The question was, estimate the time of death. So 6.13 or 6.126 is not the answer. That's just the time since the death. So you actually have to go back and figure out what the time was. Okay? A more accurate estimate of the time of death is found by taking 2 or more readings and averaging the calculated times of death. So at 9:30 a.m., the body's temperature was measured to be that. Okay? Use this one now to estimate the time of death. So t here is going to equal negative 10 times the natural log of 82.9 minus 70 all over 98.6 minus 70. So that's going to be negative 10 natural log of 12.9 divided by 28.6. Natural log of 12.9 divided by 28.6 gets me that times negative 10. So here, this would be 7.962. Okay? So this body temperature then would be, so 930, right? Minus 7 would be 230. 0.962 times 60 is another 57 minutes. So that's almost, so this TOD here would be, so that's 8 with 2 back, so that would be 1:32 a.m. Yes? Okay. Compare the estimated time of death from part A and part B. Your answers fairly close. So in A, it was what? 2:52. In B, it was 1:32 a.m., right? Are those pretty close? Depends on your, right? I mean, that's really, we're talking an hour and 20 minutes. You know what I mean? So we're talking 80 minutes in between there. Okay? Determine a more accurate time of death, so that would be an average of those two, right? So there's 80 minutes gap there, so 40 minutes in between. So our new TOD is what? 212? If I average those two? Because there's 80 minutes in between, so I either got to take 40 minutes off of A or add 40 to B. Okay. Okay. Assuming the body remains in a room with a constant temperature of 70 degrees, determine the temperature of the body after 24 hours. Okay. So that's going to be 24 here now is equal to negative 10 times the natural log of T minus 70 over 98.6 minus 70, right? Okay. First thing you would do is divide by negative 10. So negative 2.4 is equal to the natural log of T minus 70 over 28.6. Switch forms, right? Okay, when I switch forms, what do I get? E to the negative 2.4 power equals okay, how are you going to solve that one? Multiply both sides by 28.6. That gives me 2.5945 equals T minus 70. Solve it for T. $72.6. Will the temperature of the body drop to 60 degrees? Well, let's try it once. Okay? Specifically, let's look at the natural log part of 60 minus 70 over 98.6 minus 70. Right? Yeah? So can this happen? Can the temperature drop to 60 degrees? Why not? Say loud. Argument is negative, so it can't happen. Okay? What's the lowest that this body could get? 70 degrees. Okay? It's not going to get colder than the air around it. That's as cold as it can get is 70 degrees. Okay?